Hello everyone, and welcome back to another video. And just like I promised, I am now demoing the ElmorLabs PMD. Now I couldn't do it right after recording the other video because I had some USB device issues, but that is solved now. Sadly, it is not quite late, which is why I would like to apologize for the sort of bad lighting conditions on the webcam, but it should be good enough to see what's going on. So the PMD is currently kind of out of frame. You can see one edge of it right here. But what you can also see on screen is the readouts from it. So I have opened the software on my recording PC, and we're monitoring the GPU power. So the power going into these two 8-pins right here, and the CPU power, which, well, is going into the CPU. We don't have a voltage reading right now because the EVC is not hooked up. That's not really the point, so that's just going to be empty today. What I just kind of want to show off is the ability to, in real time, show you a power consumption graph in the PMD software of the ElmorLabs PMD-USB. So as for setting this one up, it's super easy. Just like connect your input cables, connect output cables, and then you get an included USB Type-C cable. Connect that to a PC. You don't need an EVC for it to work, at least for the new PMD-USB version. Just goes straight into a USB port. You download the PMD software, you select the PMD, like the USB port that the PMD is connected to, you press open, and you get your power reading. And yeah, so let's demonstrate that this is actually working in real time. So right now the GPU is idling and is pulling pretty small amounts of power, because most of the power is probably like coming through the PCI Express slot, which we can't monitor because there's no cable that we could like put a PMD in like between. But once I start the render test, you see the power shoot right up. So this 980 Ti here is the Zotac Amp Omega, and it has a quite special, not DLSS, BIOS on it. It has a 425 watt power limit, which not too long ago was a very, very high number. Now, of course, with the 3090 Ti and the 4090 existing, this is no longer a lot, but in a world where those cards didn't exist yet, this is quite a lot of power, especially for a 28 nanometer card to just ship with. That also means that this is running at basically max voltage all the time. So this thing is probably the most power-hungry, sort of just in-stock state card that I have, which is why I chose to demo it. Yeah, so board power draw 235, and the card is reading, yeah, like high 70s, low 80s on one pin, and then like 90 on 100. And what's the PMD saying? It's I guess about that. I would actually trust the PMD more than the software readouts of the card. Because like the PMD is specifically designed for that, and it has a higher, like it updates faster, it has a higher refresh rate. So, and also just Windows could be doing things, or like the NVIDIA driver can do things to a power reading, but this card is not shunt modded, so theoretically the power consumption readings in GPU-Z should line up with whatever the PMD is seeing. But you can't watch these if you run Firestrike. So we have the PMD for that, and also the PMD is just showing you like everything together. I did have, so the PMD has 2 GPU and 2 CPU channels. Now my CPU only has like the motherboard has 2 8-pins, but my power supply only has 1 8-pin, so I only have 1 8-pin connected to the CPU. And then as for the GPU, there's one single 8-pin channel and a dual 8-pin channel. And I'm using the dual 8-pin channel for the card because I only need one graph on the screen that way instead of 2. But you can theoretically split the inputs in between the channels and then monitor each connector individually, which probably would be a bit interesting to see, just to like kind of see how NVIDIA handles power balancing the inputs. But for now, I'm just concerned with total power consumption. So let's run Firestrike right here. The graphics card's completely stock, it only has a custom fan curve, so this should realistically pass. And I'm gonna go back to my recording PC and provide some commentary to the power reading that we're gonna see. CPU power is of course also there. This will be quite interesting in the physics test. Also, the CPU power consumption is quite interesting to see, just like whenever something happens in the background. Like you see those power spikes. That really high one was, I think, system info. And yeah, we're seeing 220 watts, which is, you know, considering that there's 75 watts that the card is pulling from the PCI Express slot, you know, that is close to 300 watts, just like that, like stock card. Like this thing actually deserves the three slot cooler. Like, if it wasn't for the lack of RGB and the kinda catchy looking backplate, this would probably fool up a couple people into thinking it's like a 3080 or something. But it is a 980 Ti, which I think is actually better, because 980 Ti's are cool. And I recently found out the VRM on this thing is actually not all that bad. Like, it is pretty inefficient and runs quite hot, but apparently the MOSFETs on this can handle a lot of current. So I was previously concerned with this VRM maybe blowing up, because it is just an 8-phase. But apparently the MOSFETs in this thing are so strong that even as an 8-phase, a 980 Ti is probably not gonna pull enough current to blow them up unless you go LN2. Which I actually do have an LN2 pot, but I don't have an LN2 Duo or plan to acquire one. That's what my phase change cooler is for. And unphase change, the VRM should probably still be fine. So, CPU test. Yeah, so this is what I mean. This is surprisingly little power for an 8700K at 5.3 GHz. Like, this is running 1.45 volts. That's like max safe daily voltage on this thing. Like, the CPU is delidded with liquid metal. So it's not running as hot. Like, I think it actually only touches like 70 degrees in the CPU test of Firestrike. It's not the heaviest test. Yeah, so like if the CPU was running hotter, it would be pulling more power, because that's just how it is. Like, a component that runs hotter pulls more power, which is why you often see power consumption actually coming down quite a lot when you do LN2, as long as you don't change your voltage a lot, because it's just really cold. And you can also see that the CPU is actually doing more than I thought in the combined test. Like, 980 Ti is still decent these days. And the score is also nothing to scoff at for 980 Ti. Like, this is stock. This is the stock card. I didn't overclock this. I remember I used to have a working 980 Ti Strix. Right now I only have a dead one. It's a different card, I didn't kill it. My working 980 Ti Strix went to my sister into her, like, daily PC, because she only had a 780. And I wasn't using the 980 Ti much, so I gave it to her. But that Strix had a pretty bad core. And at pretty much the same voltage that this is running, I was like... Yeah, this thing is doing 1480 at stock. The Strix maxed at 1440 with overclock. I remember fighting with the Strix to get 20,000 graphics score, and this thing's spitting out 21.6K just like that. Admittedly, my efficiency is better now than back then. But, like, I wouldn't be too surprised if, like, a reference PCB 1070 Ti would be able, like, would not beat this. Like, the 980 Ti's are kind of roughly equal to 1070s in terms of performance, though much more power hungry and less VRAM. But yeah, it's a pretty cool 980 Ti. Like, it's pretty fast stock, and the core does like 1540, I think, at max. But anyway, so enough rambling about the card. This video is about the PMD. So you were just able to see, while Firestrike is running, we get power readings, and that's with no performance impact whatsoever. Like, running GPU-Z, yeah, I can tell you graphics card power consumption, but you can look at it while the benchmark's running, and it does need PC resources which you might not want to spend if you try to get a top score. The PMD is completely external to the system, which means there's no performance impact, and you get additional things like CPU power. You get a faster refresh cycle on the PMD. Like you get a lot more graphs than you would see in GPU-Z, and just like it's just a much more efficient way of doing power monitoring. And why would you maybe want to do that? Well, having a graph for power monitoring is actually more useful than you probably think, because first off, it allows you to, for example, gauge the impact of increasing voltage. Now, as long as you're not sub-zero, you will probably end up in a situation, at least for high-end cards, where giving it more voltage might still make it scale, but your cooling might not be able to handle the extra heat that voltage will end up producing. So by taking a look at the power consumption, you can somewhat gauge, like, at what point am I just getting too much power for my cooling with like little to no benefit, because like, yeah, we have more voltage, but the card's just running so hot now that the stability remains basically the same. Because like most hardware has a point where like you give it a little bit more voltage and the power goes up like a lot. And if you see that happening on the PMD, it's probably not a good moment to keep pushing if your cooling's like air cooling or like weak water cooling or something like that. Also, like you saw on the CPU when I was doing system info, you can see power spikes. Sometimes when you're really pushing overclocks, those power spikes can actually cause crashes. And if you see a power spike and it crashes, then you know that that power spike crashed the CPU and it wasn't something else like maybe RAM, like if you do BCLK, just being unstable or something like that. I mean, I guess it was being unstable, but I've been told that the system info power spike can actually crash CPUs better than the physics test of Firestrike. So that power spike is not to be messed with. And yeah, and of course you can see like which part of the test is the most intense. You can also, like for example for CPU stress testing, you can try different CPU tests, because there's a lot of CPU tests out there. And by taking a look at the power consumption, you can also kind of gauge how intense those tests are. Like for example, Times by CPU test pulls more power than Firestrike. Cinebench probably pulls nothing. IDA 64 will pull less than Prime 95. So if you look at something that has about the same power draw that you expect to realistically max your CPU, like for example you buy a CPU that you only ever plan to do games on, and not really video editing, well, you don't really need to stress test the CPU at a video editing power level, because that's just not something that you're gonna be using it for. At the same time, like there's a thing with Prime 95. Like Prime 95 is some of the hardest tests that you can run on a CPU. It pulls so much power that it's actually becoming a problem in my opinion. So I don't like to use Prime 95 that much because it is so unrealistically hard to run that you might just end up downclocking your CPU, even though you will never even realistically hit the CPU that hard that you will actually see like instability that far. Like I had a situation where I was running, like when I had the CPU pre-deleted, like when it wasn't deleted, the stock thermal paste on this 8700K was pretty bad. So I ran Prime 95 on it and it immediately got so hot that the stability just dropped off to like 4.9 gigahertz. It can do 5.3 when it's deleted, simply because it's running colder. Like it's the same voltage that I put in before. So yeah, and if you can see the power consumption and you see, oh, like this is way higher power consumption than everything else I will ever run on the CPU, you might just not have to test that. And the capture, I didn't move the cursor for long enough, so the capture got turned off. But yeah, so there's a lot of things that a power measurement is actually useful for, and seeing this as a graph is also really, really good. Like, you know, I really favor the EVC for voltage measurements too, because it also gives you a graph. Like a multimeter is nice. You put your probes on and you get to see your voltage. But it is so useful to have it as a graph, because then you can see, oh, like when the test starts, my voltage drops by this much, or like this part of the test, the voltage drops the most, which kind of correlates with the power draw again. And then you can see like what is actually my minimum voltage, because again the EVC power voltage monitoring refreshes more quickly than a multimeter does, and is sometimes also a bit more precise, depends on how you hook it up and how good your multimeter is. But just being able to see something as a graph over time it makes it so much easier to make sense of the data. So yeah, and I think that should be it so far for the PMD. So this will become a standard thing for my recording sessions moving forward. Whenever I do like benching, I will have this showed up next to voltage. I was also testing to implement temperature as well, because when I'm doing sub-zero overclocking, I was trying to hook up my Elmor KTH to that as well. I don't have the USB version, I have the older version of the KTH, which does need to hook up to an EVC first. That can't just go right into your PC as far as I know. And sadly it seems that there's kind of a problem, because if I try to use the EVC software to both talk to the KTH and get the voltage measurement out of it at the same time, it just seems to crash the EVC. I don't know if that's a software thing that can be fixed, or if that's just a hardware thing, like an allocation thing that can only talk to one device at the same time. I don't know, the software is not my expertise. But for now, I will not have temperature monitoring because of that. Because I think voltage is, more important. And yeah, so you'll be getting GPU power, CPU power, and GPU voltage, and maybe also more voltages like memory voltage, CPU voltage if I ever do CPU overclocking, and stuff like that. So yeah. Thanks again to Elmor for sending this over. I did not have to pay for this. He just offered to send this along with other things to me. If you want to know what else he did send, I just released a video about that. So huge thanks to Elmor again for sending this stuff over. And that will be it. So I hope you enjoyed watching. I hope you learned something. Maybe I also just convinced you to get a PMD yourself, because it is a very useful tool. And yeah, so until next time, goodbye.